All right, so now we're going to look at graphically solving a system of linear equations. This can definitely be a nice visual way to see what the solution is, because we will graph both lines, and where they cross, if they cross, it will tell us that that is the solution to the two lines. Or they may cross, infinitely many times. Remember, that was from the previous video that I made about classifying these linear equations. If they are the exact same line, meaning they have the same y-intercept and the same slope, that means that they can cross anywhere on the two lines, and it's a solution for both. So we have three options for solutions. So in order to graph these, pretty easily, we want them to be in y equals mx plus b form, which is our slope-intercept form, because it makes it super easy to graph. And you can kind of see I've stepped through this over here. So first, make sure that both equations are solved for y, so they're in slope-intercept form, because y equals mx plus b, and I've color-coded. So m, that is what stands for slope in this equation, and b stands for the y-intercept. So hopefully that makes sense. It's called slope-intercept because I can see very quickly my slope and my y-intercept. X and y, those stay x and y in your equation because that's your coordinate. That's your manipulatives there that you can plug in an x to see what do you get for y. All right, so we're going to identify the slope for each. So for equation number 1, well, that's pretty easy. It's already in y equals mx plus b form. So there's my slope next to my x. Slope is always next to x. So my slope is negative 1/2. And for the second one, we're going to go ahead and do slopes first, and then we'll move to y-intercept. For the second one, I end up having to make this equal y, right? So I need to take this negative 2x, and I need to move it over to the right side because I want it to say y equals. So I have y equals 2x minus 4. I just simply moved that negative 2x from the left to the right. So now I have y equals mx plus b. So there's my slope. It is 2. All right, so now we're going to move down here to y-intercept. So I'm going to go back to equation 1 here, and I'm just going to identify what is that number that I'm adding or subtracting. Not next to the x, the number that's being added or subtracted. So that's a 1 for equation number 1, and for equation number 2, that's minus 4. So I have negative 4. So now I've identified my pieces that I need to graph these two lines, and I can go ahead and start graphing. So we're going to graph both equations. So now we're going to take a look at this, and we're just going to go ahead and start graphing. So my y-intercept for my first equation is 1. So this is on the y-axis. So I'm going to go up to 1, and I'm going to put my point. That's my first one. And my slope for equation 1 was negative 1/2. That means I'm going to go down 1 and over 2. And I can continue to do this as many times as I want. And if you're doing this on paper, sometimes it's easier to make more than one point so that you can kind of continue that over, and then you can draw your line. You can use the edge of your paper, you can use a ruler, however you need to, make that line nice and straight. The neater you make this, the easier it is to identify your solutions. If you don't do this very neatly, or as neatly as you can, I'll say it that way, then you may get the solutions a little bit muddled there. Or it may look like it's intersecting in a spot that it's not actually intersecting in. So be careful about neatness on this one. All right, so for the second one, I have negative 4. So I'm going to go back to the center here. I'm going to go down to 4. I'm going to put my point, and then my slope was 2, which means 2 over 1. If you don't see a fraction, remember there's a 1 on the bottom. So I'm going to go up 2 over 1, up 2 over 1, and I actually land right on top of that one, up 2 over 1 again. So I just kept going. Again, doing this kind of on paper is a little easier to do that with. But you can see we landed right on top of that point. So I can already see that's the point where they both intersect. So these are definitely two different lines. So we had our classifications on that last video. So two completely different lines that intersect at one point. So this means that they have one solution. There's only one spot that can be true for both equations because it's the only spot that they actually come together. So our one solution is this point, which is, I'm going to go over 2, and it's 0. So 2, 0 is my solution. So I'd either choose one solution and tell what that solution is, no solution, meaning that they are parallel, or infinitely many solutions, which means it's one line right on top of the other. And we would see that in the equation because they would be the exact same equation. So I hope that helped. That's graphically solving a system of linear equations, and I'll see you in the next video.